In 8.3, we are going to do every single thing the same as 8.1, except I call it the next level. The best way I can describe the next level is my personal experience with the difference between high school athletics and college athletics. For those of you who don't know, I did compete in track and field in high school, and then I also competed in college in track and field at a D1 University of Fresno State. The difference between high school athletics and college athletics, one was the next level and the other one was a joke. High school athletics are awesome and we think we're doing great and we think we're working hard in high school, and then suddenly when you go to the next level, you realize what the next level really is. It is going home in the fetal position. It is going into the shower and not being able to shampoo your hair because your arms hurt so bad that you cannot lift your physical hands to wash your hair in the shower. Instead, you go, it's easier to bring your head down to your hands to shampoo your hair down there because you can't lift your arms because you work so hard in the weight room that you can't lift your arms at all. True story. True story. My high school workouts were a joke compared to my college ones because college is the next level. Okay? Now, when I say 8.3, this section is going to be a lot harder than what we did in 8.1, but the rules are still going to be the same. We're still going to be doing the same things as 8.1, except when you look at these examples, they're way more complicated. There's way more places for you to make errors. But the rules are still going to be the same. We're still going to follow the same 6 rules that we did before. So, let's read a couple things. Make sure you're looking at those 6 rules. Do you know what to do with negative exponents? Do you know what to do when you're multiplying things with the same base? What do I do with the exponents and all that stuff? Couple things that I need to point out to you. When variables are in the exponent and you have to solve, the whole goal is to get things to be the same base. If the bases are the same, their exponents have to be the same. Here's what I would write down if I were you. Meaning, let me pull out my red pen. If I had 7 to the x power, and that was equal to 7 to the 8th power, then if these two bases are the same, then those two exponents have to be the same. What we're going to do to solve a lot of the problems is we're going to have to say, well, since these two bases are the same, the exponents have to be the same, so x has to be 8. Now, they're going to take it up a notch. Remember I said next level? They're going to do something like this. 7 to the x over, let's say, 12th power is going to equal 7 to the 13 over 12 power. And they're going to say, well, I hope you can figure out that x would have to be 13 for that example to work. I show that to you because that's what we're going to be doing down here below when we start the examples. If you ever get stuck, make sure the bases are the same so the exponents can be the same. Okay? Last thing. There is order of operations. You have to deal with exponents before. If I think of that, please excuse my dear Aunt Sally, you have to deal with parentheses and exponents first before you divide or multiply. That's the order of operations. So if there are parentheses and variables and exponents and then you have to do something else, you can't divide before you deal with that exponent outside of parentheses. This has to be done before you do division. Keep that in mind. All right, let's do some examples. You have the worksheet in front of you. So if you want to do this on your worksheet, do them with you can do them with me. I chose number 4 to do first. It says use exponents to fill in the blanks. A to some power times a to the 4th is going to be equal to 1. Here's what you're supposed to remember. if you go back to 8.1, we wrote down 6 rules. And there's something in Rule 5 that we're going to use that's going to help me with this. When I look at Rule 5, it says A. Some of you can't see that, so let me just zoom in on it a little bit. There's something that's equal to 1 that we wrote down in Step 5 that we're going to use in Section 3. This is the same thing as A to the 0 power. Let me write that down right below. A to the box times A to the 4th is going to be equal to A to the 0 somehow. A to the 0 is the same thing as 1. And I know that if I'm multiplying two things, I know what to do with their exponents. I need to add them. So if I know Rule 1 and I know Rule 5 that we wrote down in 8.1, it looks something like this. A to something plus 4 needs to equal A to the 0. I bet you could figure out what goes in that box that will make that true. What goes in the box? If you know what goes in the box, say that number out loud. If you said -4, you are correct, and you understand what you're supposed to do there. If you look at that, and you're multiplying the two bases, you would add the exponents. It would make A to the 0, and A to the 0 is the same thing as 1. You're supposed to realize there's two rules at the same time, which is why this is next level stuff. Let's jump to number 7. Number 7, they try to scare you a little bit. It's almost like the math teacher who wrote this went, "Moo, ha, 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 ha." But you can handle it because you should know how to switch this from radical form into exponential form. Let's do that. This is the same thing as 15. What number goes on top? What number goes on bottom? That's for the left one. Times. For the right one, we're going to go from radical form into exponential form, which means we just put the 15, and then a number is going to be on top, a number is going to be on bottom. What number's on top? What number's on bottom? And that's going to be equal, and I'm not going to touch this over here. I'm going to leave it 15 to the x over 4 power. Now there's two of these 15s over here. There's one 15 over here. I want to combine them to be the same base. I want it to be one base over here and one base over there. So somehow we have to put them together, and then this is where it becomes difficult. When we're multiplying, what do we do with the exponents? What does rule number 1 say from section 1? Do we add them, subtract them, multiply them, or divide them? What do we do? If you said add, you are correct. 3/4 plus 6/4. They're going to add together. That makes 15. 3/4 plus 6/4 is 9/4 equals 15 to the x over 4. If you find this easy, then the worksheet's going to be easy. Good job. But the hard part for a lot of students is remembering, what do those 6 rules say? How do I apply it? And now, can I figure out what x is? 15 and 15 are the same. The bases are the same. The exponents have to be the same. 9 over 4 and x over 4. How is that? What does x have to be to make that equal? X has to be 9. I'm hoping that makes sense, because this is a nice medium difficulty. We haven't got to the hard stuff yet. Next level, 9. Number 9, they have a fraction. They have this 7 to the 4/3, and they have this radical in the denominator. They're really trying to see if you know your rules. First thing I would do, though, is I would convert this denominator into exponential form. I'm going to leave the top alone. Let's say I have 7 to the 4 over 3. That stays the same. Over, and the bottom is 7 to the 6 over 9. The power over root. Power over root equals 7 to the x over 3. So I'm rewriting everything except the bottom is in exponential form. Now before I go further, we have a rule that talks about same base dividing. I can do something with that. I think it's rule 2 in the previous section. Let me take a look. Let me go back to 8.1. Let me look at rule 2. And I have this rule that talks about what to do when you're dividing, what I can do with my exponents. I can subtract them, top minus the bottom. So I can subtract these, top minus the bottom, but they're going to need to have the same denominator. Let me write that down though. 7 to the 4/3 minus 6/9 is going to equal this side, which is 7 to the x over 3. The hardest part, if you're not allowed to use a calculator, which you will not be able to on this quiz or test, you're going to have to remember, how do I do 4/3 take away 6/9? When you're subtracting or adding fractions, you got to have the same denominator. Instead of multiplying this by a 3, since we want the denominator to be a 3, is there a way to reduce this? Does 6 over 9 reduce? I hope you see it. Divide by 3 and divide by 3 will help you in that case. 7 to the 4/3 minus 6 divided by 3 is 2. 9 divided by 3 is 3. Now it has the same denominator. Now you can do 4/3 minus 2/3. Which would make 7 to the 2/3 power. And over here we have 7 to the x over 3. I bet you know what x has to be now. It has to be 2. Any questions? I have a few more examples for you. I just wanted to show you, like, it's going to get more complicated, like 24 and 22 and 14. But we'll go ahead and simplify these things and make sure that you're comfortable with them. First and foremost, number 14. The directions say our final answers has to be positive exponents. There are no parentheses here. So what I would do if I were you is I would do this piece by piece. The first thing that I do is I kind of cover this up and I say, I know what, how do I get rid of that guy? Yeah, there it goes. It disappeared now. All right. How do I do the 6 divided by negative 2? 6 divided by negative 2. I do the coefficients first. 6 divided by negative 2 is negative 3. I'm just going to put a negative 3, and the 3 is on top. The negative, it doesn't matter whether it's on top, in front, or on bottom. It's the same thing. Now you could subtract exponents. How many x's do I have up here? I have 1. A lot of times I'm going to put a 1 right there. I'm just going to add that in there because it'll make it easier as I do the problem. For most of you, you may want to subtract this, or you can move this up if you want to. Negative exponents, move them from denominators to numerators or from numerators to denominators. So if there are 2 positive x's up here, x times x, and there's 1 right there, you can put those together and get, I have 3 factors of x multiplying each other. Then the y to the negative 1 and y to the negative 1, I would probably push this down. I'd push this up. And y divided by y, or y to the 0, is going to be 1. 1 times anything is itself. I do not need to write the 1. Just kind of goes away. There's nothing in the denominator, so my final answer would be negative 3 x to the 3rd. Lots of little places for you to make small mistakes. And that's one of the reasons why I say check your answers. Look at these things. Practice the problems. 22. When you have this 3 outside the parentheses, you can either multiply exponents or you can expand. I'm going to do this with expansion. I'm going to have 3 factors of this. I'm going to have a 9t, 2 2/3, 4t, and I'm going to do 3 groups of those. 9t 2/3 over 4t, and then again 9t 2/3 over 4t. I'm going to make 3 factors multiplying each other. I'm going to just do that first. There's multiple ways to do this. This is the way that I'm going to do it so I don't make any of the common mistakes. There are other ways, but let's just do one at a time, okay? I'm going to do the denominator first. It's the easiest to do. 4 times 4 times 4, t times t times t. 4 times 4 is 16. 16 times 4 is 64. I have a 1, 2, 3 of these t's multiplying each other. That's t to the 3rd. Just kind of putting things together. In the numerator, I have 9 times 9 times 9. I know 9 times 9 is 81. Times 9, I don't know what that is, so I'm going to work it out. It's 729. Now this is where it gets really interesting. When you have a t to the 2/3 times t to the 2/3 times t to the 2/3, you would add those exponents, which would make 2/3, 4/3, 6/3, and that reduces to t squared, because 6 divided by 3 is 2. We're almost done. But we're still not done because these 2 can now reduce. The 729 and the 64 will not reduce, and I know that because 4 is made up of 2 times 2, and 9 is made up of 3 times 3, and the 3's and the 2's will never ever reduce because they're made up of different prime numbers. So these cannot reduce because they're not made of the same prime numbers, just so you're aware. I'm going to subtract. I get a negative exponent, so that becomes positive in the denominator. My final answer is 729 over 64 t to the 1st. I'm not going to write the 1 because I don't need it there. Like I said, these ones are so much more complicated, and we'll go from there. Last one, number 24. Number 24 has several different things that I'm going to do to try to get to this problem. The first thing is I can't divide until I deal with this exponent outside of parentheses. This has an exponent outside of parentheses. This one's inside. I don't need to deal with that one yet. I'm going to start with this and that. Let's start with that, and let's make there 2 groups of 6 x to the 1/3. There's going to be another one of those, 6x to the 1/3. There's 2 factors. This one I'm going to leave alone. 2x to the 5/3 over I'm going to do x to the 1/3. This exponent goes to the x, and this exponent goes to the 8. It does not multiply it. It's an exponent. Exponents can only work with other exponents. Don't forget that. Once you deal with exponents outside of parentheses, now you can follow all the rules. Now you don't have to worry about order of operations. Let's just go left to right. 6 times 6 times 2. 6 times 6 is 36. Times 2 is 72. X to the 1/3 times x to the 1/3 times x to the 5/3. We're going to be adding those exponents as the shortcut. 1/3 plus 1/3 is 2/3 plus 5/3 is 7/3. X to the 7/3 over. Down here I have x to the 1/3. I'm going to leave that alone. And I think I can simplify this, a to the 1/3. I know that this is the root, and there's a 1 out here, which means I have 1/8. But this breaks down and can simplify. The 3 means you have to have 3 to break out. Once it breaks out, you don't deal with that 3 anymore. You just have a 2 there. That simplifies to 2. We're almost done. 72 divided by 2, I can do that. That's 36. X to the 7/3 over x to the 1/3, you would subtract your exponents, which makes x to the 6/3, and that reduces 6/3 is 2, or 36 x squared as my final answer. I'm going to stop your notes right there.